Hi everyone, and welcome to my presentation on autonomous batteryless tracking devices. My name is Jan Willem Smeenk, and I'm the co-founder and chief architect at SODAQ. SODAQ has been creating autonomous devices since 2011, and we've always been pioneering renewable energy for IoT. In fact, the name SODAQ stands for Solar Powered Data Acquisition. Already 5 years ago, we found this prediction on the growth of IoT. And this chart was created by the Gartner Group, showing to us that by 2050 there would be over 100 billion IoT devices. That's a huge number, of course. And that also imposes a big threat. Big threat in terms of natural resources, big threat in terms of the environment. Because these 100 billion devices, they will most likely be battery powered. We don't have enough wall outlets, sockets to plug them in. So if you have battery powered devices, what are you going to do with these devices? Powering 100 billion devices, imagine that they are all powered by a single AA battery. So if each of them have a single AA battery and that lasts for, let's say, a year, it would mean that every year we would have 500 swimming pools of battery waste. It's a huge amount. Not only that, it's probably the natural resources that we need to create these batteries are probably soon not enough. So how are we going to deal with this? How are we going to make sure that this prophecy of 100 billion IoT devices is really going to work? Now, we envision, in fact, an Internet of Things without batteries. If these devices don't have batteries, we don't have to worry about them. But how are you going to make Internet of Things devices that don't have batteries? Well, first of all, you have to make sure that they use very little energy. And that's what has been our specialty since 2011. We've been building devices that use very, very little energy because we use the basic principles of sleep as much as you can, work as little as possible, and only communicate briefly. So you have only a very short communication cycle, and communication often takes most energy. And that means that your devices will use eventually very little energy. You measure a temperature, let's say once an hour, you pack it in a datagram and you send the datagram up on the internet. And in fact, for this communication, LORA is probably the ideal solution because in comparison to any of the other low power, long range communication technologies, LORA is doing much better than the rest of them. We've seen that the power consumption of a LORA device is typically about 10 times less while communicating than, for instance, an LTE-M or narrowband IoT device. Now, once you mastered the creation of a device that uses very little energy, you can then think of powering it by renewable energy sources. So we've been playing around with, or actually been rolling out devices running on solar energy, kinetic energy, heat energy. So all the renewable energy sources that are around, then all of a sudden come into the picture of powering your device. Now, where do you store this energy? Would rechargeable batteries work for this? Well, we've been using rechargeable batteries for a long time, and with this, you have quite significant problems with these batteries. Typically, rechargeable batteries, if we look at the LiPo battery, for instance, only allows charging between 0 and 40 degrees Celsius. That means that if you make a device that is nicely out in the sun harvesting solar energy, but it's in the Arctic Circle at minus 20, yeah, lots of energy, but no place to store it because your battery won't take it. Or looking at the example of the ear tag, the solar-powered ear tag in the ear of the cow, as we have been deploying in Australia, it's the same problem, but not with the minus temperatures, but with over 40 degrees centigrade. The cow is standing in the bright sunlight, and the interior of this device may easily exceed 40 degrees, and the charging doesn't work anymore. You can't store that energy. So that's a huge problem we have with batteries. But what probably is even a bigger problem is the limited battery life. Each rechargeable battery has a limited number of charge cycles, and after that the performance will really go down quickly, and after a while it isn't usable anymore. Take for example the car graveyard that you see in the bottom picture here. It's actually electric vehicles that are no longer used because their batteries have gone bad, and it doesn't economically pay off to put new batteries in. The batteries actually exceeding the value of these vehicles. So that's where they're standing. Nobody knows what to do with all these cars. So batteries are already a huge problem, and the problem will only get bigger when this Internet of Things prophecy comes out of having hundreds of billions of IoT devices. So how about no batteries in your device? Well, that has always been our dream. The dream of putting just a capacitor in there to store the energy and happily work forever after. The problem is that for many years this wasn't possible because the technology wasn't there yet. Now, I got good news for you. Now is the time. The technology has arrived. Over the last couple of months, we've seen some really cool supercapacitors entering the market. You can see them in the picture here. We've got these cylindrical type of supercapacitors with capacities easily exceeding 1 amp hour, or the ultra-flat capacitors of power responder. In the picture here you see a 2.5 millimeter thin flat supercapacitor that actually has a capacity of 0.4 watt hours. So it's very well usable in a IoT scenario. Now, the benefit of these often carbon-based supercapacitors is that the number of charge cycles is virtually unlimited. So that means that they have the perpetual life, basically. The other great advantage of these supercapacitors is that the temperature range is quite huge. Depending on the type, some of them go from minus 20 to plus 60 degrees centigrade, and other ones even go from minus 40 to plus 80. So you can use these capacitors whenever the energy is available to charge them with. So that for us really was a dream come true, particularly because the biggest issue that we had in the past with supercapacitors, being the great self-discharge, now seems to have been solved. We've been doing experiments with these supercapacitors by charging them and then powering them an IT device for several months, and it still worked. We've seen self-discharge of less than 1% per month, which is really cool because now all of a sudden the supercapacitor can really take the role of the battery. Now, combining that with energy harvesting, we use the energy harvester chip of EPs in a lot of our designs. We can get the best out of this solar panel. So on the left side you see a SODAQ device with a custom-made solar panel that actually doesn't just harvest energy when it's in the bright sunlight, but also in dimmed light and even indoors we manage to get energy out of them because of this super efficient energy harvesting chip. Now, combining all this technology, we finally managed to start producing our first batteryless devices. The very first one was our LOCATOR 1. A LOCATOR 1 is a settlement beacon, so that's a device that actually measures the displacement of the ground. What you see here is a device that is powered by a 4-watt solar panel. It has a couple of these supercapacitors inside, and it works round the clock. So during the day we harvest the ambient light or the solar light if there is any, store this energy in a supercapacitor, and we work around the clock with this supercapacitor storage. So it's really great. This is the first device that could run as long as we wanted to run, and we're no longer dependent of the end of life that a rechargeable battery was imposing on us for a long time. Also a great product that we're making is the SODAQ Air. The SODAQ Air is a portable air quality monitoring device. As you can see, it attaches to the handlebars of a bicycle, and you can use it to measure the air quality whilst cycling around. This has been a huge success over the last 2 years. We've deployed over 700 of these devices that are cycling around and testing the air quality. But we saw that the rechargeable battery that we had in V1 was actually the bottleneck. So after about 1.5 years, the people were returning these devices to us because the battery wouldn't hold charge long enough to make it cycle for a full day. So now we've equipped these SODAQ Air devices also with a supercapacitor. That means that we can recharge on the little USB-C port that you can see in the device overnight, and then during the day for at least 8 hours, people can cycle around and use this device on the inbuilt supercapacitor. Now, what you see in front of you now is the SODAQ Track. The SODAQ Track is our highly successful tracking line that we've announced about 6 months ago. And we're happy to say that we now also have a device that is LORA based. The SODAQ Track LORA version comes in 2 variants. We have a rechargeable version, which you see on the right-hand side, which just has a USB-C connector and runs on the inbuilt supercapacitor for a long time. And the one on the left-hand side is the solar-powered variant of the SODAQ track. As I said, also supercapacitor powered. That means that they virtually can live forever. Now, if you look in this picture here, this is actually the PCB that we designed that sits inside this casing. So in a nutshell, what you can see on the right-hand side, you saw the exposed push button, so you can trigger a message by pushing the button. It has a Wi-Fi module that we actually use for positioning, so it reads the Wi-Fi networks that's surrounding us and resolves this in a highly accurate position, so that's really cool for indoor tracking. It has a BLE module that we can use for the same purpose, so we can read Bluetooth beacons for our positioning. It has several sensors like an accelerometer and a light sensor, which we can use to trigger certain messages, and a temperature sensor, for instance, for monitoring if a shipment exceeds a certain temperature. We got some flash in terms of a serious flash module and a SD card for storing our data. And it's all revolving around the STM32WL LORA module that we use for our communication. It has a U-Blox GPS module with the white GPS antenna sitting in the middle of the device. As I mentioned before, the ePiece energy harvesting chip, USB-C connector for waterproof charging, an LED for feedback, and what is shown as the battery connector is where we actually connect our supercapacitors these days. Now, quite a few use cases that we are deploying these devices with. You see a nice map of the Netherlands and the area around us where we actively are testing these devices. And now the use cases that you could think of are, for instance, in transport. In transport, we can work out where are my assets, but also have certain temperature thresholds exceeded. Did maybe impact play a role there by using the accelerometer? Also in construction, we do a lot with geofencing, so to make sure that certain parts are delivering to a building site and that they are actually at the location where they are. Asset tracking, an important one is, for instance, theft detection. One of our clients largely use this for counterfeit protection to make sure that the shipments that they are sending out, not halfway the shipment, the actual goods are being replaced by counterfeit parts. So there's a lot of things going on that can be tracked and monitored by this new LoRa-based tracking device. So this is it from my side. I hope this triggered your interest, and if you want to know more about our batteryless LoRa-based tracking devices, please contact us at sales@sodaq.com, and we gladly tell you more about the product and help you find the right business and use cases for you to resolve with this product. Thank you very much, and bye-bye.